Hey everyone, welcome back to another lesson in MCV4U. Today we'll be looking at vector addition and subtraction. So if we're looking at vector addition, recall if we have a vector AB, the first letter again represents the tail and the second letter will represent the head. And so when we add two or more vectors, you're finding a single vector called the resultant vector that has the same effect as the original vectors applied one after the other. So there's several methods that we can use to add these vectors geometrically. The first method that we're going to look at is what is called the triangle method or the head to tail method. Okay, so here we're given two vectors. We're given vector A and vector B. So something to note here is that when we add vectors, we must arrange them head to tail. So we must arrange them head to tail. And so the resultant vector, again, starts. So the resultant vector, again, starts at the tail of one vector and finishes at the head of the next vector. Okay, so here again, let's look at our two vectors. So we have our vector B and vector A. So here, if we take our vector A, so again, tail to tip in vector B, we draw our vector A, tail to tip. And again, it starts from the tail of vector B and finishes at the head of vector A. So this would be our resultant vector, which is equal to vector B plus vector A. The second way to find, again, and add the vectors geometrically is using the parallelogram method or tail to tail. And so here we see that we're provided with an angle theta. So this is, again, the theta is the angle between vector A and vector B. And here we see that vector A and vector B are tail to tail. So vector A and vector B are tail to tail. And so here, again, we can note that if two vectors are tail to tail, we need to use method number 2 to add them together. Okay, so here, again, what we want to do here is we see that we have vector B. And what we're going to do is we're going to draw vector B top here. So we're going to redraw vector B here at the top. Again, we see that vector B that we redraw at the top and at the bottom are the same. And here again, we're creating this parallelogram. And so now we can, again, connect it from the tail to the head of the second vector. So here, and we can connect it in terms of the resultant vector, again, from the tail of vector A to the head of vector B. So here, our resultant vector is equal to vector A plus vector B. If we look in terms of the angles, we see here that angle C will be equal to 180 degrees minus whatever theta is. Okay. So note, if here we have vector A plus vector B is less than vector A plus vector B when it's split apart, and the magnitude of the sum is less than or equal to the combined magnitudes of A and B. So here, if we look at, we can draw this. If we draw, again, vector A and vector B, and this would be vector A plus B. So here, again, when can we see that there is equality? So there's equality. So if we draw vector A and vector B together, then we see that so then here we see that then vector A plus vector B would be equal to the sum of vector A plus vector B. So here we can write, again, vector A plus vector B would be equal to the sum of vector A plus B. And then here we're looking at what happens if again, the opposite vectors are added. So here, if we have vector A going from left to right, and we have vector B going from right to left, and we see that vector B is equal to negative vector A plus vector B would therefore be equal to vector A plus negative vector A, which would be equal to 0. So next we'll look at vector subtraction. So here, the relationship between addition and subtraction with vectors is similar to the relationship between addition and subtraction with scalars. The difference between vectors A and B are found by adding the opposite vector B to A using the triangle law of addition. And so here we're provided with, again, vector A and vector B. And here, if we draw vector B, instead of going from left to right, we draw it going from right to left. Again, that would represent negative vector B. Here, we could represent, again, angle C here, and then again, we're going to connect, again, now the tail to tip or tail to head from vector A to vector B. And so here, our resultant vector is equal to vector A plus negative vector B, which is equal to vector A minus vector B. Okay, so if we look at this example, it says use the given vectors to construct a single vector to represent each of the following sums. Okay, so here what I'm going to do is I'm going to just make the color for each of these. So here vector A will be in blue, vector B will be in red, and vector C will be in green. So this will help us look at the vectors. So here are the first example. Again, it says for us to show vector A plus vector B plus vector C. Okay, so if we draw vector A, so here we'll draw vector A first. Here, vector A. Then we have vector B. So here we have vector A plus vector B. And we have vector C. So again, we start from our tail to our tip, or tail to our head. So starting from vector A to vector C. And so here our resultant vector again will be here, and here again that's vector A, red is vector B, and green is vector C. Okay, in the second one, it's telling us to show, again, vector A minus vector B minus vector C. Okay, so here we draw vector A again. Again, this time we are looking at negative vector B. So instead of going from left to right, it's going from right to left. Negative vector C. Again, going the opposite direction. And so here, again, our resultant vector will again connect again the from vector A to vector C. So again, we'll label this vector A, negative vector B, and negative vector C. Okay, so let's keep going here. And so here it says the diagram shows a rectangular box. Determine the vector equal to each sum. So A is vector AD plus vector DH. Okay, so vector AD. So again, I will just use different colors. And so here for A, vector AD plus vector DH. So here, vector A to D vector d to h. And so here, again, the vector equal to each sum. So here, from vector a to vector h, or sorry, from a to h, so it'll be vector ah. For b, we have vector ab plus vector bf plus vector fg. So vector ab plus vector bf plus vector bfg. So here, start vector a to b, vector b to f, and then vector f to g. So here, again, we will get from point A to G. So here, again, it would be equal to vector AG. So again, we want to, again, look for tail to head continually. Okay, for C, we have vector AE plus vector HC. So again, here we know that vector AE is the same as vector DH. And so we can write that. So here we can also write it as DH plus vector HC. And so here we have vector DH plus vector HC. And so here we see that, again, we connect that together. Again, our resultant vector will be vector DC. And finally, for D, we have vector AD plus vector AE plus vector AB. So here, again, we can see that vector AE is the same as vector DH. So just write that again, or draw that again. And we know that when we see that vector AB, so vector AB is also the same as vector HG. So here we have vector A to D, vector D to H, and then vector H to G. And so here, this will be our resultant vector from A to G. So here, again, we can rewrite this again as vector AD plus vector DH plus vector HG, which is equal to vector AG. Okay, so here it says given triangle ABC, again, express vector BC in terms of vector AB and AC. So here, we see that, again, we want our B to be our tail, and our C to be the head. And so here we can write vector BC, again, tail being B, C being the head, is equal to negative AB, vector AB, plus AC. Because here, if we see that, negative AB plus negative, or plus AC will give us our vector BC here. Okay, in example 4, it says given vector u is equal to 3 and vector v is equal to 4, and the angle between vector u and v is 125 degrees, determine u plus v. Okay, so here, again, it gives us the angle between u and v is 125. And here we know that when we are given the angle between two vectors, the vectors are arranged tail to tail. So here, we'll draw. First, we'll draw a vector v. And here we know that that's given to us as 4 in terms of its length. And here we have vector u, and here the length is given to us as 3. You know that, again, the angle that is between the two is 125 degrees. And so here we're determining, again, u plus v. So here we can draw, again, vector u. Again, we'll use our second method in terms of solving for the addition of vectors, again, which is the parallelogram method or tail to tail. And here, so we're drawing, again, vector u, which is the length 3. And so here, see that we are looking for u plus v. And again, if we draw the angle, then the entire angle is 125 degrees. And then the angle over here is 180 minus 125. Well, that here is 55 degrees. Okay, so here, to look for the length, we can use cosine law. So here, cosine law, and write r squared is equal to 3 squared plus 4 squared minus 2 times 3 times 4, so it's 55. R squared is equal to 9 plus 16 minus 2 times 3 times 4, goes 55. R squared is equal to 25 minus 24 goes 55. And here, r squared is equal to 25 minus 24, calculated cos 55, is approximately 0.5736. R squared is equal to 25 minus 13.77. R squared is equal to 11.23, and therefore R is equal to 3.35. And so here, the 3.35 is just the magnitude. However, we also need to determine the direction, which is the other qualifier of a vector. So, and we also need to determine the direction, which is another qualifier of a vector. Okay, so here, if we know that the dotted blue line is 125 degrees, here this is beta, and then we'll label this angle beta. And so here we can see that if we use sine law, we can see that sine 55 over what we just found, 3.35, is equal to sine theta over 3. And so here we see that sine theta is equal to 3 sine 55 over 3.35. So theta is equal to 47 degrees. And then to find beta, we see that beta is equal to 125 minus 47 degrees, and beta is equal to 78 degrees. And so here, if we take this, then we can see that therefore u plus vector v is 3.35, 78 degrees counterclockwise. 78 degrees counterclockwise of vector u.